The Ionic Bond 5.2. We learned in the first video that elements react in order to obtain a full outer shell and so become stable. Metals lose electrons to form positive cations. Non-metals gain electrons to form negative anions. An element cannot lose electrons unless another element takes them. Metals and non-metals are therefore perfect partners for both to become stable. Let's look at an actual example of sodium and fluorine. Sodium loses one electron to become the sodium 1 plus ion. Fluorine gains this one electron to become the fluorine 1 minus ion. The positive sodium ion attracts the negative fluorine ion to form a bond. This bond is called an ionic bond, as it is made up of ions. Ionic bond and ionic lattice. Metals form positive ions and non-metals form negative ions. The positive cation attracts the negative anion, forming an ionic bond. Remember, it is called an ionic bond as it is made up of ions. Millions and millions of ions come together to form an ionic lattice. Notice that each positive cation is surrounded by 6 negative anions, 4 around the sides, 1 at the back and 1 at the front. Each negative anion is also surrounded by 6 positive cations. This is the structure of salt, sodium chloride. In the case of magnesium and fluorine, the magnesium atom needs to lose 2 electrons. Fluorine, if you remember, is only willing to accept 1. Magnesium can still give away 2 electrons, but this time to 2 separate fluorine atoms. As each magnesium ion bonds with 2 fluorine ions, we must show this in the formula MgF2. This shows that magnesium is bonded to 2 fluorine ions. Water is another example, with the formula H2O, where oxygen is bonded to 2 hydrogen atoms. Worked example 1. Find the formula of the compound formed between lithium and fluorine. There are 2 simple rules to find the formula of a compound formed from ions. Rule 1 is to find the stable ions for the atoms. In this example here, lithium is in group 1, so has 1 outer electron. It must lose this to form the lithium 1 plus ion. Notice lithium is stable with 2 electrons in its outer shell, here its first shell. Fluorine, we know already, forms the stable fluorine 1 minus ion. The second rule is to combine the 2 ions together to make a neutral compound. In this case, just 1 lithium ion and 1 fluorine ion is neutral. The formula is therefore LiF. Worked example 2. Find the formula of the compound formed between sodium and oxygen. Rule 1 is to find the stable ions for the atoms. Sodium is in group 1, so it loses 1 electron to form the sodium 1 plus ion. Oxygen is in group 6, so gains 2 electrons to form the oxygen 2 minus ion. For the second rule here, we need to combine 2 sodium 1 plus ions with 1 oxygen 2 minus ion to get a neutral compound. The formula is therefore Na2O. Practice question. Find the formula of the compound formed between aluminium and chlorine. You should pause the video here and try to work out the formula by yourself on a piece of paper. I will show the solution on the next slide. Please pause now. Practice question solution. Find the formula of the compound formed between aluminium and chlorine. Rule 1 is to find the stable ions for the atoms. Aluminium is in group 3, so loses 3 electrons to form the aluminium 3+ ion. Chlorine is in group 7, so gains 1 electron to form the chlorine 1- ion. For the second rule here, we need to combine an aluminium 3+ ion with 3 chlorine 1- ions to get a neutral compound. The formula is therefore AlCl3. I hope you managed to get that answer. If not, and you don't understand why, then I recommend you review the video again. You should now complete the multiple choice test, the Ionic Bond 5.2.